over a couple of problems here on limits from the AP test. This is from the no calculator section, so you're expected to be able to do these problems without the use of a calculator. Our first problem here is the limit as x approaches infinity of 5x squared minus 3x plus 1 over 4x squared plus 2x plus 5. Now, if you remember the handy little trick of horizontal asymptotes in our rational functions, our horizontal asymptote, since we have an x squared as the highest degree on the top and on the bottom, we're just going to divide our leading coefficients here, and we get 5 over 4. And that's our limit. Super simple, really easy. Now, if you don't remember that for any function like this, any polynomial function, or rational function rather, all we have to do is we can divide the numerator and the denominator by the highest power of x, which in this case is x squared. So we're going to divide every single term here by x squared. So we have 5x squared over x squared minus 3x over x squared plus 1 over x squared all over 4x squared over x squared plus 2x over x squared plus 5 over x squared. And this does look like a mess, that's fine. So we simplify it up a bit. We end up with 5 minus 3 over x plus 1 over x squared all over 4 plus 2 over x plus 5 over x squared. Now, if we look at this, we're looking at as x approaches infinity here. So as x gets larger and larger and larger, this thing here gets smaller and smaller and smaller. If x is 10, we have 1 over 100. If x is a million, we have 1 over a trillion. That goes to nothing. So this here goes to 0. Same thing here, goes to 0. Here goes to 0. Here goes to 0. So we don't care about any of this stuff, and we're left with, as x gets really, 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 really large, 5/4. And that's our answer here for our first question. So our second question here probably looks a little bit more scary than the first one. The limit as x approaches 0 of 4 times sine x cosine x minus sine x all over x squared. Now you probably see the trigonometry here, freak out, close the book, walk away, done with the class. But no, it's not that bad. What we want to remember is we have these two things, these two special limits that we have to remember whenever we're doing trigonometry. And those are that the limit as x approaches 0 of the sine of x over x is 1, and the limit as x approaches 0 of 1 minus cosine x all over x is 0. And really conveniently, we have a lot of sines and cosines here, along with a little x squared in the denominator. So a little bit of manipulation to this, and we're going to get this. We can bring our 4 right out to the front. Constants go to the front, we don't care. So it's 4 times the limit as x approaches 0 of the sine x cosine x minus the sine of x all over x squared. And I'm going to rewrite this. We're going to factor the numerator a little bit. We're going to get 4 times the limit as x approaches 0 of the sine of x times the cosine of x minus 1 all over x times x. And the reason for doing this is if we separate this a little bit, we get this. We have the limit as the sine of x over x times the limit of the cosine of x minus 1 over x. And this is a product. It's two things being multiplied together. If we multiply these original things here, we're going to end up with what we had up here. So let's separate this farther. So we get 4 times the limit of x approaches 0 of the sine of x over x times the limit as x approaches 0 of the cosine of x minus 1 over x. And now we're almost there. You can see that this part here looks really close to this piece up here, just the order of subtraction is different a bit. And if we want to deal with that, we can just factor the negative out of our numerator. And we get, I'm running out of space here, 4 times the limit as x approaches 0 of the sine of x over x times, take out our negative 1, times the limit as x approaches 0 of 1 minus the cosine of x over x. And now we have our thing, we have a couple of things here. We have a 4 in the beginning. That's great. Now this piece right here, limit as x approaches 0, sine of x over x, we have that right up here. We know that's 1. So it's 4 times 1. And then our times negative, whatever our limit over here is, 1 minus cosine x over x. Look at that, 1 minus cosine x over x. That's convenient there as well. And that ends up just being 0. And negative 0, 0 doesn't matter. 4 times 1 times 0 is and will always be 0. Thus we go up here. Our answer is C, 0.